Hello everyone, hope you're doing fine. So today I'm here with another topic from physics portion, that is electric charges and fields, 12th physics. And what we'll be calculating? We will be calculating the value of electric field on the axis of a circular charged ring. Let's say this is the circular charged ring. The charge would not be concentrated on a single point, but it would be distributed throughout the ring. And what we would be calculating? We'll be calculating the electric field on the axis. That axis passes through the center of mass. Okay, what is the magnitude of electric field on any point? That point would be on the axis of that circular ring. So let me draw here a circular ring. So I would be drawing it very differently because that would make my calculations very easy. Okay, this is some circular ring. Is that okay? Even though it doesn't seem to be a circle, but for the point of convenience, I'm drawing it like this. Okay, and let's say this is some axis passing through the center of mass. Passing through it is center. This is the circle, and let's say this is the axis passing through it is center of mass. And let us say I'm going to calculate here the electric field, magnitude of electric field, because the charge, let's say I put a charge plus q on this circular charged ring, and this charge would not be concentrated on a single point, but it would distribute itself throughout the ring. For example, I put 20 coulomb of charge on the ring. This 20 coulomb of charge would be distributed throughout the ring. Let's say 1 coulomb, 1 coulomb, 1 coulomb, 1 coulomb, and that equals to 20 coulomb. And then since this is some charge here, it would definitely create some electric field, and that would reach here because of the whole ring. And then what we would be calculating, we would be calculating the electric field, total magnitude, net electric field here on this point. Is that okay? Okay, so see let us say the radius of this circle is r, and this point is at a distance of x from the center of the circular ring, and let us say this distance is small r. Is that fine? See, the formula we would be using that to calculate the electric field of a single point charged object. Let us say if we have some plus 3 coulomb of charge here, and we need to calculate the electric field at this point, and let us say this point is at separation of 2 meters, and then the value of electric field would be k times this source charge divided by distance square. Is it okay? And where k is 1 by 4 pi epsilon 0 if the whole thing is put in air, and then 3 coulomb divided by 4. Is that okay? But we cannot directly use this formula here. Why? Because this formula is applicable only to point charged, that small body, small charge, okay, point sized objects. But since here the ring is not point sized, okay, it is a continuous body, it is some distribution of charge, we cannot use directly this formula here. That is why we're gonna go for a different approach. Okay, so see what I'm gonna do. I'm gonna take a very small element of charge here, dq charge. This dq will be the portion of this total charge. The total charge of the ring is capital Q, but I'm taking here the very small element, very small element that would be containing some charge dq. Let us say 1 coulomb. I'm putting, let us say, 50 coulomb to the whole ring, and I'm taking very small portion of the ring that would be containing, let us say, 1 coulomb of charge. So this 1 coulomb is very small as compared to the 50 coulomb. So I can consider this important point. I can consider this small element as a point sized charge. So I can use directly that formula. If I had to calculate the electric field at this point due to this small charge, that electric field would be very small. Okay, dE very small because the charge is very small, the electric field would be very small. Okay, that would be equal to the k times source charge dq divided by distance square. Exactly, I'm using that formula. Why? Because I'm approximating the situation. I'm taking very small charge element here, and I'm calculating the electric field at this point. I'm not taking the whole charge because that whole charge is distributed throughout the ring, and that ring is not a point sized object. Okay, but here this dq is a very small point sized charge, so I can use this formula directly here. Is that okay? So that is the approximation we're going to use. Okay, see, and if you write the value of k here, if whole thing is set in the air, then k is 1 by 4 pi epsilon 0, where epsilon 0 is the permittivity of space. Okay, see, now this electric field would be in this direction. Why it would be in this direction? Because this is some positive charge, and the electric field line due to a positive charge goes away from the source. Okay, this electric field will be like this. Had it been the negative charge, then the direction of electric field would have been this. Is that okay? And let us say this is some angle theta. Okay, I'm sorry to write it as a Q. Sorry. Let us say this is some theta angle. And this would be exactly theta. Why it would be theta? Because these are vertically opposite angles. Is that okay? Then using the vectors, this component of electric field would be dE sine of theta. And this component would be dE cos of theta. Is that okay? If you don't know this, if this is some axis, x-axis, and if this is some y-axis, and if this is some vector r, and if some theta, then this component would be r cos of theta, and this would be r sine of theta. That is called the projections components of a given vector. So this is some dE cos of theta, this is some dE sine of theta. But remember here at this point, the electric field due to this portion would be like this, dE, exactly. Why? And this would be r, because that point is equidistant from every point on a circle. This is some circle, and I'm calculating electric field at this point. So this distance would be equal to this distance, would be equal to this distance, because this point is on the axis that is passing through its center. So every point on that ring would be equidistant from this point. So that is why this would be r, and every length would be having the same angle with that point. Suppose this point is making some angle theta with the top point, and this point would be making same angle with this point. Okay, because we're measuring the angle with that axis. Okay, that axis passing through the origin. Okay, so this would be theta as well, and this would be theta, vertically opposite angles, and its component would be dE cos of theta in this direction and dE sine of theta in this direction. So the electric field dE sine theta, because of this element of charge, would be cancelled by dE sine of theta because of this charge element. You understand? So this is some electric field dE because of this portion. So it has two components, dE cos of theta in this direction and dE sine of theta in this direction. Exactly. So another, here it was a dQ element. Its electric field would be in this direction, and it has two components. Okay, dE sine of theta downwards and dE cos of theta in that direction. So dE sine theta would cancel this dE sine theta. So similarly, so this component of the ring would have electric field like this, and it would have two components, dE cos of theta and dE sine of theta. And similarly, the left portion of the dQ, okay, so that would create electric field this way, and it has two components, dE cos theta, dE sine theta. So this dE sine theta, this dE sine theta would cancel each other because they are in the opposite direction. Okay, so dE sine theta, every dE sine theta would be cancelled by another dE sine theta. Okay, so this dE sine theta, the dE sine theta, this would be cancelled by dE sine theta, this. Okay, the dE sine theta from this portion would be cancelled by this dE sine theta. You understand? So what remains? So there remains only dE cos of theta. So if I need to calculate the net electric field, that would be simply integral of dE cos of theta, because what remains is only dE cos of theta. Every dE sine theta element would be cancelled by another dE sine of theta. You understand? And since the dE cos theta, if I need to calculate the net electric field, I would have summed if it had been a discrete system. But since this is a continuous body, I cannot use the summation. I have to go for the integration. So, and if I here substitute the value of dE, it would be simply k times dQ divided by r square and cos of theta. See, k is some constant, 1 by 4 pi epsilon 0, and r square would be also constant because this point is at equidistant from every point from the ring. Okay, see, this point, some r, okay, you understand? So this r would be constant, and cos theta would be also constant because this point makes angle same with this every point on the ring. Okay, so cos theta would be constant as well. Integral of dQ. And if I write here E net, that would be k divided by r square and cos of theta. And integral of dq would be q. Simple. Charge. Integration of dx is x, integration of dy is y, integration of dz is z, integration of dq is q. Or simply, if I'm integrating this dq, that would be giving me total charge 1 plus, that would be giving me 50. You remember the example, okay? Okay, one more thing. So that would be k q divided by r square. If I calculate the value of cos theta from this triangle, cos theta would be base divided by hypotenuse. So I would replace cos theta by base divided by hypotenuse. You understand? This is some, I would make it here. If this is some theta and this is some x, this is some small r, this is some capital R, I can write cos theta as base divided by hypotenuse. K q x divided by r cube. Is that okay? I can manipulate a bit. Since I can use Pythagoras theorem as well. So it would be giving me like this: r square is equal to x square plus capital R square. R would be equal to x square plus capital R square to the power 1 by 2. And if I substitute that here, that would be giving me k q x divided by, I replace r with x square plus capital R square to the power 3 by 2, because I have 3 here. Let me check whether it is visible from here or not. So it is not that visible. I would write it here. Okay, E net would be given as k q x divided by replacing r here, x square plus r square to the power 3 by 2. It was 1 by 2 here, and because we had already 3 here. So this is the final result. This is the final result of net electric field at this point due to some circular charged ring having total charge of q, and this point is at distance of x from the center. Okay, is that clear? Okay, let me discuss here some 2 cases. You can replace, importantly, you can replace this k by 1 by 4 pi epsilon 0 q x divided by x square plus r square to the power 3 by 2. If you want to write that in permittivity of space, is that okay? Just remember this formula, or just try to understand this formula, what is telling. And I'm going to discuss here 2 cases. Okay, one case would be, I would be calculating electric field at the center. Okay, so case first. So now I would try to calculate the electric field at the center of the ring. This is some ring and I want to calculate electric field at its center. So see, at center, the value of x would be 0, because I am taking the distance of this point from the origin. If I am getting close to the center, one point would reach when I would reach at the center, then x would be 0. So if I substitute x to be 0 in that formula, that would be giving me k q divided by into 0 and something 0 plus r square to the power 3 by 2. So that is 0. So electric field at the center due to some circular charged ring would be 0. Okay, this is a mathematics, and if I'm going to discuss it as physics, so the physics would be like this. This is some center and this is some dq. Its electric field will be like this. This is some dq. Its electric field will be like this. This is some dq. Its electric field will be like this. This is some dq. Its electric field will be like this. So this is cancelling this is cancelling this, and this is cancelling this. So every electric field will be cancelled by another electric field. So net electric field at the center would be 0. This is physics and this is mathematics. Okay, another case would be, I am calculating electric field at very far away point. Okay, this is some ring and I'm going, let's say 10 kilometer, 20 kilometer away from this ring, and I want to calculate the electric field at that point due to this circular charged ring. So then I would be case second would be x greater than r. Okay, you understand? The distance of the point where we're calculating the electric field is very far away from the ring. That means it is radius. Is that clear? If I substitute, so I can neglect this r. in comparison to the x, because x is very, very greater. Suppose I have some 1 lakh in my pocket and I'm putting 1 rupee in that. So that is not changing that much. So this x would be very, very big in comparison to r. So I'm neglecting r in comparison to x. So the net electric field would be 1 by 4 pi. If you're compatible, then I can write in terms of k, because it is easy to write. K q divided by x square to the power 3 by 2 and x. So this 2 would go k q x divided by x cube. 1 will go with this k q divided by x square. This is mathematics. Now I'm gonna tell you it is physics. So this is the value of electric field at some point which is very, very far away from this ring. So see, if I'm going very far away from the ring, then from that point, because this ring is very, very far away from me, I cannot see this ring from that point. I would see a small charged object having charge q. Okay, because the far I go from this ring, this object would be, it would seem as a very small object. Once I go very, very far, it would go small, and now from 20 kilometers from this charged ring, I would see a single charge plus q, and it would be like this, plus q. This is some very far away, 10 kilometers, 20 kilometers. Okay, then electric field would be given by simply k times source charge divided by distance square. I'm using that point object formula. Okay, the formula that electric field would be given by source charge divided by r square multiplied that constant. Is that okay? So this is some physics and this is mathematics. Is that clear? So I hope you understand it. So the whole thing I'm going to recap here. We had some charged circular ring and we calculated its electric field value at some point on the axis. That axis passes through the center of the circular charged ring, and that the value that came out to be k times q, that is charge on a circular charged ring, the distance or the separation of that point from the center, and divided by x square plus r square to the power 3 by 2. You can replace k with the 1 by 4 pi epsilon 0. That is completely fine. And then we discuss the two cases. One is at center, the value of x would be 0 because we're measuring the distance from the center itself. So x would be 0, we're substituting, and electric field came out to be 0 through mathematics, and this would be physics, and that would be also giving the electric field at the center as 0. And another case, that is if we go very, very far away from the ring, then the electric field value came out to be k q divided by x square, and that's completely fine. The physics also gave us the same thing. Okay, because when we go very, very far away from the ring, this ring would not be visible as a ring, but it would be visible as a point object. Okay, point charge. So that would be k q divided by x square. Is that clear? So thanks for watching.